Welcome to the Explainer. Today, we're going to tackle a common coding headache and turn it into one of your most powerful programming skills. So, have you ever found yourself writing some code and then a little later you're copying and pasting those exact same lines over and over again? Yeah, that's a classic problem that pretty much every single programmer runs into. But what if there was a better way? What if you could write that code just once and then use it anywhere you need it as many times as you want? Okay, let's dive into how to do just that. Well, the solution to our copy-paste problem is something called a function. The easiest way to think about it is as a reusable package of code that's designed to do one specific job.
Functions are, without a doubt, the building blocks of clean, efficient programs. They save you from that copy-paste trap, and they make your code so much easier to read and understand.
So how do we actually create and use one of these powerful tools? Let's just break down a really simple example. This program here defines a function that adds two numbers together, and then it calls that function to get the result. Okay, it all starts with that def keyword. That's how you tell Python you're defining a function. You give it a name, in this case it's mySum, and then you specify the placeholders, a and b, for the data it's going to need to do its job. Then, down in the main part of our program, we call the function just by using its name. And when this happens, something really cool occurs. The main program literally pauses, and control jumps right over to the function's code. But, this whole process introduces a new kind of subtle problem. See, functions create their own little worlds, or as I like to call them, their own little bubbles. So what happens when a variable inside one of those function bubbles has the exact same name as a variable that's outside of it? Check this out. Here, we have what's called a global variable, a, that we've set to 10. But then, inside the function, we assign a totally new value of 100 to a local variable that's also named a. And here is the absolutely crucial part. Changing the local a inside the function's bubble has no effect whatsoever on the global a that's outside of it. They are completely separate. This separation is a core concept in programming called scope. It's basically a set of rules that Python uses to keep all of our variables from interfering with each other and causing total chaos. So to figure out which variable to use, Python follows a really strict search order. It's known as the LEGB rule. First, it looks in the local scope, right inside the function. Not there, it checks any enclosing functions. Still no luck, it looks in the global scope, which is the main part of the program. And as a last resort, it checks Python's built-in names. The very first one it finds is the one it uses. Okay, so now that we understand that these function bubbles are separate, how do we safely pass information into them? You're going to hear these two terms thrown around all the time, and while they're definitely related, they mean very different things. So here it is, the key difference. Parameters are those placeholder variables you put inside a function's definition. Think of them like empty boxes. Arguments are the actual values, the real data that you put into those boxes when you call the function. I love this slide. This is actually a brilliant analogy I saw in a Reddit discussion that just makes the whole concept click into place. But hang on, there is one final critical gotcha that trips up almost everyone when they're first learning about passing arguments. You see, Python treats simple, unchangeable, or immutable data, like numbers and strings, differently than it treats complex, changeable, or mutable data, like lists. And this example shows it perfectly. Just look at the code and then the output. Notice how the function completely fails to change the name Bob, but then look at the list of ages, it changes it. So why did that happen? It's because the string person is unchangeable, so it was passed by value. Python made a safe copy of it for the function to use. But the list ages is changeable, so it was passed by reference. That means the function got a direct link, a direct pointer right back to the original data. So let's just quickly bring it all together. Here are the key things you should really take away from all this. Mastering these concepts really transforms you from someone who just writes code into someone who designs elegant, powerful solutions.